Here we go. Yep, we're live. So, kia ora koutou, ko Andrew Takaingua. I am here today to present to introduce you to Sujata. Sujata is the head of science at Taita College, and she'll be going over the level 2 chemical radioactivity exam. These webinars are brought to you by Study It. So Study It has helped fund these webinars and bring them all to you. In the chat, you'll notice the PowerPoint. I've already put the link, so it's LinkedIn, and that's the PowerPoint that Sujata will be going through. If you have any questions, just post them in the chat, and I will either ask Sujata or just save them until the end. So I think that's about it. Right, over to you, Sujata.
Kia ora, students. I'm Sujata Rajgopal, Head of Science at Taita. As I told in my last presentation on Saturday when we did the other two standards, what you have all studied your content. Now, what this webinar I will be focusing on is how do you write your answers to get your top grades? Because I'm very sure at this point yes, it's a last minute revision and what you know your contents, but how do we put them all together to get our best possible grades? And this is one of the easiest topic where you have learned half of them, that is in the chemical reactivity, you learned half of this topic last year. So it's a quick revision on that part, those parts. Then the additional parts in this is your equilibrium questions and your pH calculations, along with calculating the concentration of an acid or a concentration of a base and calculating the pH. So it is a simple, straightforward paper, which should not take you much long. And I've put the websites for if you at all need more revisions, more practice, please go to this website. It has the entire lot of the past question papers, and topic wise they have arranged it rather than solving an entire question paper. But you want to just focus on the areas which you are not that confident. Please go to this website. They give you a short synopsis and you will succeed. Okay. The first part, most of the time we have observed in the last so many years, is about the questions about the rate of reactions. We know that the 4 rate of reactions are concentration, temperature, surface area, and catalyst. So the first thing is to talk about the collision theory. What does the collision theory tell you? The collision theory talks about, yes, if the particles need to be in the right orientation and they need to collide with each other, the right temperature for a reaction with the right activation energy for the reaction to take place. Again, so you are talking about now when you give an answer to this surface area concentration, please ensure you are referring to what the reactants are there given in the question paper. If you write a general answer, it looks that you have rote memorized and you wouldn't get any credits for it. So, or any points as such. So please refer to the reactants that is taking part in the reaction. Now, if it is concentration, look at which of the reactants concentration has increased. Normally it is an acid. So you would say as the concentration of the acid increases, there are more particles of the whatever. If let's say if it's an HCl, so you will say more particles of HCl is available for reaction. If it is surface area, let's say calcium carbonate is made into a powder. So you would say as calcium carbonate is made into powder, more particles of calcium carbonate are exposed for collision. So that's what you have to make very sure of, so that you include the reactants names in it. Then link so if it is you're talking about concentration, you need to tell as more particles are available for reaction, there is a higher. Now, please pay attention to the words which I'm talking. Therefore, the number of collision increases. That means the frequency of successful collision increases per unit time, per unit volume. Remember, when you are looking at concentration, you are not changing the volume of the acid, or you're not changing the volume or the amount of your reactants. You are only taking the same amount of reactants but only increasing its concentration. So the reaction rate has to increase per unit time, per unit volume. And therefore, your rate of reaction is faster and the time taken for reaction is less. Same thing as you're talking when the graphs are given to you, you are linking your graphs to that, and you will see as at the start, it is faster and then it slows down. So you are saying most of the particles have been used up. There's less particles available for collision. Therefore, the reaction is slowing down. And then at the end, yes, it has tapered down. So that means the reaction has come to an end as all particles have been used up for collision. So you need to talk about it. And if you have given two graphs, you need to compare and contrast, but remembering that both the graphs, whether if one is at a higher temperature, other is at a lower temperature, the end rate at the end product would be the same, only because that's the only amount available and they have all coming out the same thing. The other thing you need to remember is that when a reaction is changing, the factors are only to change or speed up the reaction. The mass or the volume produced will not change, whether it is at a lower temperature or at a higher temperature, or a more concentrated or a lower concentrated or more surface area. The mass of the products will not change. Only the factor has been done to speed up the reaction. So be very careful while answering. Remember, nothing changes except only the rate of reaction is changing, not the amount or anything is changing here. Here I put a diagram where you can see what is happening. Factor if increased, surface area increases the frequency of collision, increased rate. So temperature increases the energy of the particles. The particles' energy, what they get is kinetic energy. The heat energy transfers to kinetic energy. Therefore, the particles vibrate faster, increases the frequency of collision, and more percentage or more number of successful collision. Now, catalyst is the odd one out. Now, catalyst do not take part in the reaction. Now, a classic example, what I tell my students is, with the COVID hitting us the last couple of years, we have seen that though we need 80 credits for level 1, it reduced to 72. For level 2, 54, because your 20 comes from your level 1. Out of the 60, you need only 54 credits. So, but that means, so when you lower the number of credits, the number of people passing level 2 increases. But is the ministry writing the exam? No, you still have to write the exam. So the ministry acts as a catalyst. So here the catalyst, what the catalyst do is lower the activation energy so that the particles can collide with each other for the reaction to take place. So the catalysts themselves do not take part in the reaction. They only help the particles which have very low reaction. They lower the activation energy, giving the particles some energy to help to react with. So again, factor increase. So when you're talking about to write your answers, if the concentration is increased, more particles in a given area, therefore more chance of collision. So if the surface area is increased, more particles. Now you see that in the only difference between concentration and surface area is in concentration, when you're increasing the concentration, more particles are available to react. Whereas in surface area, you are exposing more particles for collision because you're powdering them. You are exposing the particles for collision. You're not increasing the number of particles, but the particles are already there. But by powdering them, you are exposing more particles for collision. Temperature, yes, you need to mention kinetic energy, because when you increase the temperature, you are giving heat energy to the reactant particles. And what you are doing is, and because of the heat energy, they get more kinetic energy that makes them vibrate faster and therefore more successful collisions. Catalysts do not take part in the reaction. They only lower the activation energy, makes a pathway for them to succeed. Now,
just some questions, if it's fine. There's a few built up, so I'll go through them. Someone asked, how do you know when to use AQ, meaning aqueous, in equations? How do you know when you're going to put that in?
Oh, okay. If they're saying it's a solution, means it is aqueous.
Cool. How do you know that ammonia hydroxide can also be ammonia using chemical reactivity logic? I'm not sure what that means.
No, I couldn't get the question.
Okay, we'll just hold on. How do you know that ammonia hydroxide can also be? Okay, I'm not quite sure that question makes sense. Abby, you might need to rewrite that. And I think at the end, Abby asked, could you also go through neutral salts, acidic salts, and basic salts, and how to identify them? I'll let you answer that at the end.
Yeah, it will come. It is there in the PowerPoint.
Yeah. Someone asked, do we also say per unit time and per unit volume in all collision theory questions?
Yes.
Cool. And that was, the question about ammonia is copy and pasted out of 2015. Could someone put me the number and I'll quickly find like the exact question and I'll quickly look it up. And I'll let you carry on, Sujata.
Okay, thank you.
Oh no, someone they asked you can say that ammonia is either named ammonia or ammonia hydroxide. Why?
Because the main thing is that with ammonia is that what you are doing is you're splitting them into ammonium ions, NH3 ions and OH, because when it comes from the ammonium hydroxide, remember it has to split into its ions to make the aqueous solution. And that is why we are looking at the conductivity, and therefore you can either way write it. But so here is what we are identifying as a conjugate base of an acid and a base. You identify which is the conjugate base or conjugate acid. So that's why you can either name it either way.
Okay, hopefully that answers your question. If it doesn't, Abby, just let us know.
Yeah.
I think that's it for now. Cool.
Now, when talking about equilibrium questions, remember your Le-Chatelier's principle is very important. You begin your answer with Le-Chatelier's principle. So now when you're talking about equilibrium, remember this is when we talk about equilibrium only if it is a reversible reaction. Okay, so what do you mean by reversible reaction? The reactants become products and the products then, so the reaction goes back and forth. But when you say it is in equilibrium, the amount of the reaction is stable and it happens at where your number of products and the number of reactants remain the same. That's when you say that the reaction has reached an equilibrium state. Okay, so it is a back and forth. It's a back and forth reaction, but at a point in time where your number of reactants will be equal to your number of products, you will say that the reaction has reached an equilibrium state. So while answering again, remembering that the equilibrium of a reaction changes with temperature. Okay, there is always a shift in the equilibrium position due to the shift in temperature, and we'll go through that. What happens to the equilibrium constant Kc when you change the temperature, but it doesn't get affected much by pressure. Okay.
Just to have a bank of more questions, if that's all right.
Yep.
What's next? What are the three species? I'm not sure what that means.
Okay, I'll tell you. Yeah. The three species, what you're talking about is the hydronium ions, hydrogen ions, but that is very less, and the hydroxide ions. Okay. So these are the main thing. For an acid, it is hydronium ions. For a base, it is hydroxide ions, where you're looking at the concentrations. And from that, you can calculate your equilibrium constant from the given equation.
Okay, cool. That hopefully answers that one there. The next question was, I don't understand why there are three species when it ionizes. So hopefully that answers that question, doesn't it?
Yeah.
Cool. And then someone asked, is it only the concentration that you say per unit volume, or is it for all?
For every one of them.
Okay, cool. Next question was also for the aqueous question. Even when it is not in solution, sometimes they put S for solid or L for liquid.
What's that? Sorry.
So someone asked also for the aqueous question. Even when it is not in solution, sometimes they put S for solid and L for liquid. And then the next question, the follow-on to the thing is, do we have to write AQ after the name of a chemical? Will we get penalized if we don't?
No, luckily for y'all, you don't have to write the state. It is not a requirement at level 2, but at level 3, yes. Why we give it to you in an equation is, especially when you are writing your equilibrium constant equation, because if the given in an equation, if one of them is a solid or a liquid, you do not write the concentration of it. It is taken as 1. And I will show you a PowerPoint on it. So in an equation, while writing the equilibrium constant, this is how you will write it. So give me a second. I will change the slide to that so that clarifies for you. Give me a second.
That's fine. Cool.
Yeah.
And that's all the questions.
Yeah. Now, students, look at this question, this 2016. The ionization of water is represented by the equation 2H2O liquid is equal to H3, that is hydronium ions, plus hydroxide ions. So first to write, if you want to write the equilibrium constant of this one, remember H2O being a liquid, you will not write the Kc. So what you will write as a Kc is the concentration of hydronium ions times the concentration of OH minus ions. That's it. Because the concentration of H2O as a liquid is 1. So hope I've made that clear for you all. So even so whenever a liquid or a solid is given, you do not write the Kc. I'm trying to see if I can get a exact where it is written. Yeah, I'll come back to it when I get to it, I will show you.
Just continue with the PowerPoint, and we'll answer those those questions at the end.
Yeah. So here you see that the equilibrium constant is written. It is always product divided by your reactants. Okay. So the concentration, the capital C stands for the ion, whatever is there, or the substance, and C, the smaller one, stands for the number of moles. So if you have 2 H2O, the H2O concentration of H2O comes in the bottom, and the 2 goes on the top to the power of 2. So Kc is, that's how you write it, where the smaller letters represent the number of moles of each of the substance taking part in the reaction. So how to write the answers? The answers is to first write out your equilibrium constant expression in full. Okay. Then now sometimes they give you an equilibrium constant and tell you it has the reaction reached the equilibrium position. So what you do is the equilibrium position or the equilibrium constant Kc is given to you in the exam, but what your job is to find out whether that equation has reached or that reaction has reached an equilibrium state. So your job is to first find out you calculate from the values that are given. The concentrations are normally given. So using that concentration, find out your equilibrium constant, your Kc. And if the answers in chemistry, you have to be careful. Please round it to 3 significant figures. If you do not do it, you lose your marks. There is an error being calculated. So every of your values should be in 3 significant figures. That's a standard given. And then once you have calculated for that equation which have been given to you, you calculate your equilibrium constant. And if that doesn't match the one which is given to you, you say it has not reached. And then what you have to say is whether the given one is higher or lower compared to one. And if it is lower, then it needs to be increased to reach to the equilibrium constant. And what happens to the reaction? The reaction moves forward. So that's what you have to talk about. So you need to remember the certain rules of the equilibrium constant. If the equilibrium constant is greater than 1, then it moves to the right, that is, it favors the products. If it is less than 1, then it is in the reverse direction. It is moving towards the left. The reaction is more towards the left, favoring the reactants. And if your Kc is way high than 10 to the power of 20, then you know that it's a very fast reaction favoring the products. But if it is and that the reaction is being complete, so you say if your Kc value is more than 10 to the power of 20, then you will say that the reaction is complete. It's totally done. But if your Kc is less than 10 to the power of negative 21, remember that the reaction has not even started. It doesn't have enough activation energy for the reaction to begin.
Just some other questions. What does the Q constant stand for when they ask you to calculate Kc and see if it is in or out of equilibrium?
Okay, Q is the given Kc. That's the other word for it.
Okay. Hopefully that answers that. When asked if something is acidic or basic, should we refer to it as accepting or donating a proton, or whether it produces an OH or H3O plus in solution?
Now, an acid is a proton donor, and then base is a proton acceptor.
Cool. One more question. How do we answer this? The ionization of water is represented by the equation. It's got two H2O, H3O plus plus AQ, then OH minus AQ, give an account of the extent of ionization of water given Kw equals 1 times 10 to the negative 14.
Yeah, so you have to first find out the concentration of the hydronium ions. Yeah, and that is negative. The pH will be given to you. So the concentration of hydronium ions is 10 to the power of negative or negative, whatever your pH is. So if you're using a graphic calculator, remember, please do not use your exponential button for that. What there's when you look at your graphic calculator, you will see, I'm not sure, I don't have one with me right now, but on your graphic calculator, there is where the log button is written. On top of that, 10 to the power of x is there. So press your shift key and press that. That means 10 to the power of negative. So while calculating the concentration of hydronium ions, it will be 10 to the power of negative pH. So the pH will, and from there, you calculate the ionization constant, Kw is given to you. You have to calculate the concentration of hydroxide ions. Now that is, so Kw divided by concentration of hydronium. So the Kw is equal to, Kw is equal to concentration of hydronium ions times concentration of OH ions. So from there, now you know that how to calculate the concentration of OH, that is Kw divided by the concentration of hydronium ions. So once you calculate the concentration of OH, remember you have to calculate the pH of, so the pH of the solution will be of the, if it's a base, so you have already been given the pH of the solution. So from 14, take away that will be the concentration of whatever the base you are acting for.
Cool. Hopefully that's answered that question.
Yep.
And that's it. That's all the questions for now.
Okay. Yeah, this is, see this? So this is what you need to remember. So Q value is nothing. It's another way to, it is the equilibrium constant given to you at a particular temperature. Okay. So that is, and then you're comparing the one which you have calculated and compare it to it and see what is happening, whether the reaction, they are the same or they are at equilibrium, or if more reactants they are favoring it, if is the reaction going towards the reverse or towards the front or moving right, moving left. So these are the things you need to remember. Now, if you see here in this where I've told you about now here, if it both are, all are in gaseous state, therefore you look at the gaseous state, see, so that it is the Kc is the concentration of the products divided by the concentration of the reactants. So it is 2 moles of NO gas is produced. So it is the concentration of NO to the power of 2 divided by, there is only 1 mole of N2 and 1 mole of oxygen. Therefore but they are both in gaseous state. But if you have anything in solid state, you need not put it. It is just calculated as 1. You need to put them only if they are in gaseous state, not in liquids and solids. But if it is in aqueous, you need to put it. But if it is liquids and solids, please do not put them. So now here I've solved so for this, how I've written the equilibrium constant. So, and when you know that from your year 11, that if your delta RH, that is the enthalpy of your reaction, is negative, it is an exothermic reaction, means heat is given out. If it is positive, it is an endothermic reaction, that means heat has to be supplied. So the following chemical write an equilibrium constant. This normally comes for an achieved 1. And if you have to calculate the constant, it comes for a merit. But from there, you have to also calculate the pH with the KW. Then you need to, it goes for an excellence part. So now what does the Kc value represent? So a decrease in the value of your equilibrium constant means the concentration of product is reduced. Because why? How do you calculate your equilibrium constant? It is the concentration of the products divided by the concentration of the reactants. So if the Kc value is less, it means the concentration of product is lesser than the concentration of the reaction. If the Kc value is higher, it means the concentration of the product is higher than the concentration of the reactants. So what it says again is, the concentration, the equilibrium constant will decrease with decreases when the temperature increases, and leading to an exothermic reaction. And Kc increases when the temperature decreases, reverse one. In an exothermic reaction, this is happening. In an endothermic reaction, what happens? Kc increases when temperature increases, and Kc decreases when temperature decreases. So that is when your delta RH is given to you. So once again, I repeat, in an exothermic reaction, the Kc will decrease when the temperature increases. Kc increases, temperature decreases. So here, if such equations are given, please write your full equation, balance your equation, please. So they will not tell you, it is a given state that at level 2, you need to know to balance your equations. So write them, and then why it is not at equilibrium, you need to tell what is happening to so depending on your Kc value, you can tell that if the Kc value is less, it is not in equilibrium. If it is more, very high, then also it is not in equilibrium, because it has to match the values. But remember, the reactions, read through if the delta RH is given, is it exothermic or an endothermic reaction. Kc is always affected by temperature. Now, this is a template I've made for if you have any questions relating to pressure, concentration, temperature questions. Again, repeatedly, the first thing that comes is state your equilibrium principle. So your Lee-Chatelier principle has to be mentioned. Then just find out what the factor is, and link increasing the principle to how the system responds. Okay, sometimes the questions will be decreasing. So what it means is that, is the pressure being increased? Is the pressure being decreased? Or is concentration being increased? Or is the temperature being increased or decreased? And link that factor to how the system will respond. That means whether it will go in the forward, is the equilibrium going to be shifted to the right, or is it going to be shifted to the left? What way it will favor the reaction? Will it favor towards the products, or will it favor to the reactants? And what needs to be done to get to that position? Okay. So that's what I've said. When you're saying here, the general here in point 3, you are just telling a general rule, and then from point 4 and 5, remember, you have to link back to what is a question given. And so there wouldn't be such a question, but the question would have an equation given. Please refer and link to the question. so that you are taking your reactants and your products from your equation. Do not write a generalized answer. For the first two parts, it's okay. Yes, you are showing that you know your theory. Now, the application of theory is in 4, 5, and 6. So go back to your question, see what is your products, see what is your reactants, and please use them in your exam. This is what I've done. So use this slide. The slide has been put in your chat. So you use this slide to answer your questions about the equilibrium and the factors changing it. So in terms of pressure or concentration or temperature. Now, what are the conditions being changed? If the concentration is being changed and there is a increase in products, the direction of change in the equilibrium position will be in the reverse direction. If there is a decrease in products, it is in the forward direction. Increase in the reactants, it is still in the forward. And if it is a decrease in the reactants, it is in the reverse direction. Pressure. If you increase the pressure, it is in the direction with the least number of moles of gas. If it's decreased, in the direction with greater number of moles of gas. So you have to see in which direction the moles have been given more to you. So in that way, the reaction will proceed. Now, if you are increasing the temperature, now remember, students, this is we are talking not the rate of the factors affecting the rate of reaction. These are the factors which affect the equilibrium position of an reaction. Increase. If the temperature is increased, it is in the direction of the endothermic reaction, where means the products need the concentration or the amount of products, the enthalpy of the products is higher than the enthalpy of the reactants. If the temperature is decreased, it is in the direction of the exothermic reaction, which means the enthalpy of the reactants is greater than the enthalpy of the products. That's why you get a negative sign, because your delta RH is delta H of the products, take away the delta H of your reactants. If a catalyst is added, there is no change in the equilibrium. Only it affects the rate at which the equilibrium is maintained. Now, the other one is about pH and conductivity questions. So here, now this is where you have to talk about remember, every time an acid will dissociate into its ions in a solution. So if it is HCl, it will dissociate into H plus ions and Cl minus ions. If it is H2SO4, it will be H plus ions and SO4 negative ions. So that's what it is. So, but you are not writing H plus, what you are writing is H3O, that is hydronium ions. Okay. So acid means hydronium ion. So when I'm writing, okay, write the dissociation of HCl acid, you will write Cl minus plus H3O negative ions. If I'm writing about H2SO4, it is SO4 negative 2 and H3O minus ions. That's why it dissociates into a strong acid always completely dissociates into its ions in the water. Okay. And acids are called as proton donors because it gives out H plus ions, and the bases are called proton acceptors because they accept. Then you have the amphithetic substances. That means at times they will act as a proton acceptor, or at times they will go as a proton donator. So they are the few of them. But some of the key weak acids you have to remember. Some of the common weak acids are any carboxylic acids and the amine ones, and all the unfamiliar weak acids or bases you will be given, so you know that. And for all strong acids, it is a concentration of H3O plus ions, that is the hydronium ions, and for all bases, it is OH negative ions. So you are writing and then what you have to do is relate to the conductivity of the materials. Now remember, all salts will have high conductivity. Weak acids, weak bases are low in conductivity, whereas all salts are high in conductivity. Strong acids, strong bases are high in conductivity. So they are the general properties you should remember. This is a general summary of your pH calculation. Now, what is pH? It is a negative log of. So in your, if you're using a graphic calculator, there is next to your exponential button, there's a negative sign in brackets. That's a sign you press. It's a negative sign. Then the log button and the concentration of H3O, that is hydronium ions. Now remember, students, this is given to you. Okay. Now Kw is your ionization constant. That is this. And in pure water, your Kw is 1 into 10 to the power of negative 14. Okay. So use this triangle too. And if the pH is given, calculate acid concentration. If pH is given, then the concentration of the hydronium ions is 10 to the power of negative pH. So see here, that's what I've written. Press your shift key and above your log, there is a 10x symbol. So that's what it comes. Press your negative sign and your number of the pH. Calculate OH if HO3 is given, calculate OH3O, but sometimes Kw is given, so you can calculate either one of them. Now, this is the summary of the acids, what I was talking to you. When you're looking at, they talk to you about the conductivity. Now, strong acids, they completely dissociate into hydronium ions. And this is an example I've taken of HCl, Cl minus. There no acid remains and they have high conductivity. That is because it fully dissociates. Okay. And the pH is low between 1 and 2. Now, weak acids like your ethanoic acid or your vinegar. So what happens? It dissociates again because it's an acid. It has to give hydronium ions and CH3COO negative. But it is a weak acids do not completely dissociate. In water, it does only a partial dissociation. So that means some acid molecules are still remain in the water or in the solvent. They are weak, therefore they have low conductivity and they have a high pH. What they mean by high pH is the number is between 3 to 6. Acid salts, they all completely dissociate. So NH4Cl dissociates into NH4 and Cl minus. And that will further dissociate into what? H3O and NH3. So whenever an acid salt is given, you have two things to write, 2 steps to write for your ionization. First is the acid salt itself dissociating into its 2 ions and it further dissociating into hydronium and its other conjugate as base. So when it is acid salts, they completely dissociate. So therefore, they have a high conductivity, and their pH is between still 3 and 6. So water concentration is assumed to remain constant, so it is always left out. Now the summary of species in base. Strong bases. So strong base, sodium hydroxide. See that because it's a base, it has to have OH negative, and then it's sodium ions. Weak bases, NH3. It will dissociate into OH minus and NH4 plus. And here, why it doesn't completely dissociate in water, therefore, and some molecules are still left, therefore they have a low conductivity and their pH is low, it is between 8 to 11, and whereas the strong bases have a high pH between 12 to 14. Base salts. Just like your acid salts, they completely dissociate. Here, you see that they are first dissociating into their respective ions, and from there, they are further dissociating into hydroxide and their conjugate base. And it has high conductivity, but the pH is low between 8 and 11 because it's a base salt. This is some examples I had shown last time to the students who wanted to calculate the pH, so I had shown them. And that is the end of the slide, the presentation. Hope you have all got something out of it. Any more questions, please ask me.
Right, so I'll just go through the list of the questions because there's quite a few. We'll start a little bit further up. I think that's been answered. When do you add H2O to a reaction, and when do you not?
Normally, in a H2O is added whenever they say you have to dissociate an acid or a base. H2O is added because their dissociation has to be in water.
And someone asked, how do you know use it? When do you use an equilibrium arrow rather than normal reaction arrow? And someone gave the answer, fully dissociates equals single arrow. So I assume it means is there any more to that?
Yeah, but what the student, whoever answered is, so if they say it is fully, your Kc is equal to 1, then or greater than 1, it is fully dissociated. So therefore there is no more reaction. The reaction is complete, and therefore it is a single reaction. It won't proceed further. But if it has not reached an equilibrium position, then you do your double arrow.
Cool. Hopefully that explains it. Oh, sorry, yeah, I explained it further down. How do you know which one undergoes hydrolysis?
It would be mentioned to you. They don't expect you to remember everything. They will give you whether it is hydrolysis happening or not.
Okay. Next one. When a basic salt dissociates, does it completely disassociate OH and ions, or is it just OH?
No, completely. Base salts, it will completely dissociate. So first when you're writing, so it's a two-step reaction you're writing. First you are dissociating into its two ions, and then you take your base, conjugate base ones, and then you show the further dissociation into hydroxide ions. And so I'll show you, I'll share the one which I've written.
Just whilst you're opening that up, for basic salts, does it have to dissociate into two ions and then one ion reacts with water to form OH minus?
Yeah. I'll just show it. There it is. Here it is. Yeah, completely. So base salts, complete dissociation. See that? So it is dissociating into its two separate ions. And then the weak base further reacts with water, to give your hydroxide ions and your weak base.
Okay. So when do you disassociate a neutral acid-base solution? Is it a liquid, aqueous, or gas? I'm guessing it's liquid. But
Liquid, yeah.
Yeah, okay, yeah.
Liquid, or it could also be aqueous.
Okay, cool. Do you add water to put them into ions in a salt?
Yep.
Cool. Someone asked, what's hydrolysis? I have no idea.
Hydrolysis is splitting of your water into its hydronium ions and hydroxide ions.
Cool. I'm pretty sure that answers that. Do you add water to disassociate salts into ions?
Yep.
You do? Yep. I think do we answer this? For basic salts, does it have to disassociate into two ions and then one ion reacts to form water? I think we answered that. Yeah. Someone else said, why does it say CH3COO equals Na plus? I'm guessing that's on the diagram. Why does it, on the diagram you've got, for the complete dissociation, you've got CH3COO minus is equal to...
So here it is, so Na is your positive salt, sodium, separates, and then you have CH3COO, which becomes a weak conjugate base. And that is the one which, because we are talking of base salts, the conjugate weak base has to further dissociate to give you hydroxide, because sodium is a metal, it won't give you any. It is separating it out for and giving you only the base part, which will further with water will shift into hydroxide ions and form your weak conjugate base. So acid. So you see CH3COH is a weak acid.
Cool. What does the equal sign mean?
It splits into two.
Okay, that's what I was wondering. The next question, I don't understand why a neutral salt is always liquid or aqueous when it dissociates into ions.
That is from what you have learned now. When you're making your salts, last year you would have, when your level 1 science, when your acid-base reaction, to get your salts, it is always in your aqueous state or a liquid state. And what do? You evaporate it to take out the water, and what remains is your solid base salts, correct? Or your metal salts or whatever. So they have to be always that the reaction can only happen when it is in an aqueous state, where their ions have to be split, and then only the ions can rearrange. Otherwise, a reaction cannot take place.
Okay, I think this is the last question. Do you need to state symbols?
You mean about the aqueous, liquid, things like that?
I think so. So do we write NaCl aqueous, or do we just write NaCl to Na?
If you know it, write it, but do not write it wrong. If you are confused about it, leave it. Okay,
cool. Right, I think that's all of the questions. Right, so I think it's 24 past. We might close off. Oh no, we've got one more question. Are we required to state negative/positive charges like Na plus?
Oh yes.
And if the base or acid partially dissociates, then do we always need equilibrium arrows to show it reacts with water?
Yes.
And I think that's it.
Yeah. So remember, students, for all your calculation, your answers has to be in 3 significant figures. That's a must. So that is what you have to be careful about. And when you, unlike in other subjects, when you have further calculations, we take the whole answer to do the calculation. In chemistry, we do not do it. Like you might have done in physics, if you have a part of your answer and you have the entire answer, you do not round it and use it for the next calculation. Use a complete answer. But in chemistry, it's the other way around. You always have to shorten it to 3 significant figures, and that 3 significant figures are taken for your next answer, not the complete answer what you get on your calculator.
Cool. And there's one more question. Can we quickly go over conductivity and ionic salts?
Ionic salts, okay. Conductivity in acids. So it is this is acid salt. So ionic salt is here. This is an ionic salt. See that? It's a complete dissociation into its to NH4 and Cl negative. And then this weak acid will further dissociate into H3O plus hydronim ions and NH3, which is its weak base. Any other?
No, I think that's it. Right. Right, we'll close off the session for today. So thank you, Sujata, for spending your time to help these students out. And I think that's really about it.
Yeah. Thank you, students, and wish you all the best. I'm sure you all know what to write. Anything, please, as Andrew had said in the beginning, if you have any more questions, put it in Study It, and the teachers across the nation would answer for you. So all the best. Do well.